This is section 10.1, and this is on solving quadratic equations. So a quadratic equation is an equation that has a highest power of 2. So these equations solve differently than linear equations. The linear equations are the ones that don't have that squared term. And those are the ones where you just kind of get your variables on one side, your constants on the other, and then you divide. With a quadratic, something that has that highest power of 2, we have to take a different approach to solving these. So the different approaches that we're going to look at are factoring, which we're not going to do a whole lot on because that was covered back in Math 90, which is the course right before this one. This is why it's going to be really important that you go back to those prerequisite sections that are assigned from Chapter 6 and reacquaint yourself with factoring if you feel like you're kind of still struggling with it a little bit. I'm not going to be able to do a whole lot with teaching it because we have other stuff to cover. So we've got the square root property, completing the square, which we'll do in this section, and then we have the quadratic formula, which we will do in 10.2. So if you haven't already completed the prerequisite sections for Chapter 6, I would strongly recommend that you go ahead and get that done before you attempt Chapter 10. Okay, so just a quick review on factoring. If you have a quadratic equation, like say x squared minus 15x plus 50 equals 0, we have to get it equal to 0 first. Then we factor this. Now this one factors by what I call trial and error. That's where it factors into 2 parentheses. Because this is x squared, that splits up into x times x. And you have to split these two numbers. You have to find two numbers who will multiply to give you positive 50 and who will add up to give you negative 15. So over here is just me kind of running through that list of the two numbers that will multiply to give you 50 and add to give you negative 15. And this is the pair that I came up with. So we get this minus 5 minus 10. Remember, factoring is the opposite of the distributive property. The distributive property is when you multiply all this out and combine your like terms. Factoring is the opposite of that. So if you were to factor this out, if you were to multiply all this out, distribute it all out, you should get this. Now once we get these factored, because it's equal to 0, we know that something times something else being equal to 0 means that one or both of these is going to be 0. So once we get this factored, we can split it and solve each one of these factors separately. So we end up with the two solutions of 5 and 10. That's something to notice here. Quadratics always have two solutions. They may have two solutions that are the same number, but in any case, you always do have two solutions for these quadratic equations. All right, so let's look at another example here. So like I mentioned before, you want to get this into standard form. That standard form is the equal to 0. So if it doesn't start off in standard form, you have to get it in standard form. That means you may have to move some terms around. In this case, I have to move that minus 48 to the other side by adding 48 to both sides. So in doing so, boom, standard form. That's the ax squared plus bx plus c equals 0. When you're factoring, the first thing you always want to look for is a greatest common factor. Don't just dive right into like some trial and error or the AC method or anything like that. See if there's a common factor, a greatest common factor that you can take out. In this case, 3 is your GCF. So I took this 3 out of here. Now remember, factoring something out is the opposite of the distributive property. So if I were to redistribute this 3, I would get this equation back. Now, I kind of drew this kind of little barrier here just to show you this 3 is gone. It's kind of pulled out there. It's just along for the ride now. But this factors more. You can factor this further by using trial and error. I know it's trial and error because if there's a 1 right here, that way I can use trial and error. If this coefficient is not a 1, then I tend to use the AC method, but I can also use trial and error too. It just kind of depends on the numbers. Okay, so taking this, factoring it more, I need two numbers who multiply to give me positive 16 and add to give me negative 8. And those two numbers are minus 4 and minus 4. So now that I've got this completely factored, I'm going to go back and rewrite my equation in factored form. Now, when you split these apart, you may wonder what happens to the 3. Well, because the 3 doesn't have a variable, it doesn't like split off and do its own thing. If this were 3x, then I would have 3x equals 0 to solve. But basically all I'm doing is dividing both sides by 3, so I can just eliminate that 3. So I can just take these factors right here, set them equal to 0 and solve them. And look, I do get the same answer twice, but that is considered two answers. It's called a multiplicity of 2. Okay, another one. This one's in standard form. So x squared minus 4 equals 0. See that equals 0, that's what we want to see. This one's going to factor by a special case called the difference of two squares. So the difference of two squares formula is this, A and B business. This is the difference of two squares. You can write it as x squared minus 2 squared, so that, you know, x is your A and 2 is your B. So this factors as x minus 2x plus 2. Alright, so splitting those apart and then solving those separately, we end up with the two solutions of x equals 2 and x equals negative 2. Alright, so now we get to do some new stuff. Solving using the square root property. The square root property is awesome. It only works in special cases, but when it does work, oh my goodness, it is so great to use. So let's go back to this one, this x squared minus 4 equals 0. We can use the square root property on this. I can move this 4 to the other side of the equation and make it x squared equals 4. So I realized that by showing my work here, I kind of covered up some of my work. So with this one, I took this x squared minus 4 equals 0. And I added 4 to both sides. All right. That gave me x squared equals 4. This will allow me to use the square root property. If you can get it into the equation into this form of something squared equals a constant, then you can just take the square root of both sides. Because this is just asking you, what number can you square to get 4? Well, there's two numbers. There's 2 and negative 2. So what we can do is take the square root of both sides, but we got to be careful because you know this symbol just represents the positive square root, and there's going to be two answers. So what we have to do is say that I'm going to take both the positive and the negative square root, because both of those answers will satisfy that equation. So when you take the square root of both sides, you do have to bring in this little plus or minus, which is telling you that there's going to be two answers. So we get plus or minus the square root of 4, which is plus or minus 2. That is the abbreviation for two answers, 2 and negative 2. This is just the compressed form. So if you ever see that plus or minus 2, that's just a nice little, shortcut for writing the two answers to negative 2. All right, so let me summarize this for you. So to use the square root property, it has to be in this form of x squared equals c. Then we could just take the plus or minus square root of both sides and get this. Now, there is a little variation of it. If this happens to be like x like plus or minus some number, not another x though, but just like plus or minus some constant, and that quantity squared, then we can still use the square root property. This one you'll see a little bit later when we do the completing the square way of solving quadratics. It's a little messier, and it's not my go-to. My go-to is usually if it factors, well, square root property first if I can, and then if I can factor it, otherwise I'd use the quadratic formula. All right, so y squared equals 30. That one is just set right up for the square root property. We're going to take the plus or minus square root of both sides. This square root's going to undo that squared, and you're just going to get y by itself. And here we get plus or minus the square root of 30. If that simplifies, let me dig out my calculator real quick. If that square root of 30 were to simplify, you would need to simplify it. So how do I know it doesn't simplify? Well, grab the calculator, do the square root of 30. See, it doesn't simplify. There's no perfect square factors of 30. Don't write a decimal, because Hawks is not going to like that decimal. So use those exact answers. All right, next up, 5x squared equals 245. Don't go and take the square root of both sides. Notice that coefficient up here has to be a 1. So let's divide both sides by 5 to get the x squared by itself. Then we'll use the square root property. So if we divide both sides by 5, remember this is 245 divided by 5, that fraction bar right there means division. So you can just grab your calculator and use that one. And we'll get x squared equals 49. And then in red here, I took that plus or minus square root of both sides. And we know the square root of 49 simplifies. It just gives me 7. And then we get this plus or minus. This plus or minus shows up as a result of taking the square root of both sides, because there are two solutions. Because if you square a positive or a negative, either way, you're going to get 49 out of it. So those are two answers, 7 and negative 7. Remember, this is just the shortcut way of writing those two answers together. All right, this is another one that's like C up here. We need to divide both sides by 49. Don't let the m scare you. It's no different than an x. So if I divide both sides by 49, I don't get something quite as nice as before, right? I divided this out and got 49, which was a pretty nice number when it comes to square rooting stuff. Here I get a fraction. I get 16 over 49. Ugh. But that's okay, because when I go to take the square root of both sides, the square root of 16 is 4, and the square root of 49 is 7. So it still works out to be pretty nice. And of course, the plus or minus is in here. Now, if it feels like I'm moving fast, remember you do have the pause button and the rewind button, so you can always go back and re-listen to this. Okay, so the square root property on this other form, this is setting us up for the completing of the square. So in this form, the squared is by itself. Don't go and multiply that out. I mean, you could distribute all that out, move the 36 over and factor it, or use the quadratic formula, but let's not. Instead, let's go ahead and take this plus or minus square root of both sides. So in doing that, that square root's going to undo that squared. Here we're going to get plus or minus the square root of 36. So that here gives me that x minus 2. In the previous examples, we were used to taking the square root of that squared and just having x and being done. This adds an extra step to the process. Because here, plus or minus, I don't know if you can see that, but that's plus and a minus right there. I know that minus looks like it's kind of going into that radical symbol there, but I promise you there is a plus or minus right there. The square root of 36, which is 6, so we get plus or minus 6. I have to go one step further now, and I have to add 2 to both sides to solve it for x. So here's what I have to do. There's 2 answers here. There's 6 and negative 6. So I have to add 2 to both ones. So what I did was I split this up into the 2 equations that it is. X minus 2 equals 6. That's positive 6. And x minus 2 equals negative 6. and then added 2 to both sides and got these two solutions. So normally with the square root property we would be done right around in here, but because we have this extra step right here, we gotta do all this extra work. Now if you can do this in your head, that's awesome, all right? But just remember, this is a 6 and a negative 6, so don't just add 2 and try to make it plus or minus 8, okay? This is 6, and then you add that 2 over, and then, or we have negative 6 and you add the 2 over. So be really careful with that. There's, I see a lot of students make mistakes and end up with 8 and negative 8 by accident. Okay, so let's do another one like that, just to kind of get you a little more familiar with it. First, we need to divide by this 3. We need to get the squared by itself. So dividing both sides by 3, I end up with x minus 6 quantity squared. 147 divided by 3 simplifies to be 49. Now I've got it set up in this kind of standard form for the square root property. I'm going to take the plus or minus square root of both sides. That gets rid of this squared. So I get x minus 6 equals plus or minus 7. All right, here's where the new stuff comes in. I now have to add 6 to both sides. So, because I was running out of room here and I was too stubborn to go to another page, I wanted to keep it all on one page here. So I just came over here and wrote, okay, we got plus or minus 7, and then I have to add 6. There's 2 computations happening here. Do not do 7 plus 6 and get 13 and then just do plus or minus. That's not the case. These signs are on this 7. These signs are not for both of these numbers, right? So this is actually 2 computations. So pay close attention to my use of color here. It is very intentional. So 2 computations. I've got the positive 7 plus 6, which is 13, and then I've got negative 7 plus 6. So negative 7 plus 6 is negative 1. Don't accidentally do negative and then do 7 plus 6. Because if that's the case, then you're also throwing that negative onto that 6, which is incorrect. Okie dokie. So let's look at x squared plus 25 equals 0. To use the square root property, we need to subtract 25 from both sides to get that squared term by itself. In doing so, we get it set up for the square root property. We take the plus or minus square root of both sides, but hold up. Look at that negative. How are we going to take the square root of a negative? Well, we're going to go back to chapter 9 and we're going to use imaginary numbers. Yay! Don't roll your eyes at me. I know you're doing it. So remember, that square root of that negative is going to form an I, that imaginary, and then the square root of 25 is 5. So we get 2 answers, plus or minus 5i. Oh yes, just when you thought it could not get any better, it's possible to have imaginary solutions. All right, let's talk about completing the square. So I wrote out all the stuff here, as always, but I want to kind of talk you through it. In completing the square here, you're going to be given this blank to start with. So let me just show you where this starts. We have x squared plus 10x plus something, and that's going to factor just like that. So we have to find this magic number right here. So you can see I put 25, but like, how does that work? Well, our goal is to find this magic number, you know, that you can add to both sides of the equation, essentially, that will make this factor into the same thing twice, essentially completing the square. Okay, so here's what we're going to do. We need to find this number. There is a process to find this number. You don't have to just yank it straight out of your butt. If you take half of this x term and then square that number. So half of 10 is 5. 5 squared is 25. 25 is what's going to complete the square. So if you take half of that, what I call the middle term, because I know there's going to be a third term here, so half of that middle term squared. Now, what does this factor into? You don't actually have to review your factor rules here. You can figure out what it's going to be based on what you just did, this process. Whatever sign is right here, that sign's going to go here. This half of the middle term before you squared it is the number it's going to go here. So look closely at my use of color. It is very, very intentional. Okay, see how that's in green and that's in green? Red, red, that's very, very intentional. Okay. Now, if you wanted to check it, if you multiplied out this, x plus 5 quantity squared, it should simplify to be x squared plus 10x plus 25. Or, if you wanted to factor it, you could take that and you can factor it and see that it factors into the same thing twice, or that thing squared. Right? So we're completing the square. We're finding the missing thing that'll make this a squared. Why do we want to do this? Well, because then we can go back and use that square root property. So, okay, so let's look at another example then of completing the square. Excuse me. All right, so let's find this magic number that's going to go here. This magic number is always half of that middle term, or that middle number, middle coefficient, squared. So half of 8. Now, do I have to use the negative? No, because I'm going to square it. So half of 8 is 4. 4 squared is going to be 16. So that magic number is going to be 16. What is this going to factor into? Well, that's a subtraction, so that's going to be a subtraction. This is going to be a 4 because of that half of the middle term. Pretty cool, huh? All right. This was a little trickier, though, because we're going to have some fractions. This is a 1 right here, so half of 1 is a half, and then a half squared is a fourth. They're a little messier, but the same process. Same process as before still works. Half of 1 is a half. That's a plus, so that's a plus. Now, how did I know that a half squared was a fourth? Because it's 1 half times 1 half. So 1 times 1 is 1, 2 times 2 is 4. Okay. This is another one that's going to have some fractions to it. Half of 9 squared. So if I take half of 9, I'm going to get 9 halves. And then if you square it, you get 81 over 4. Same sign. Half of 9 is 9 halves. All right, so let's just review what we got so far. To solve by factoring, you're going to get the stuff equal to 0, factor that left-hand side, set each parenthesis equal to 0, and solve. If you're going to solve using the square root property, you're going to have to get the squared stuff by itself. So that's a big difference. In factoring, you need that stuff equal to 0. For the square root property, you need the squared by itself. Then you're going to take the square root of both sides. And you're either going to have that form where the x squared is by itself, or you're going to have some plus or minus constant attached to it. Don't forget the plus or minus here. That is really, really important. Don't forget that plus or minus, because then you'll forget one of the solutions. To solve by completing the square, we're going to complete the square, factor it, which is what we just did in the previous examples. I showed you how to complete the square and then how to factor that, by using the same sign as what's in the problem and then the half of the middle term kind of business. Then we're going to utilize the square root property to finish solving it by completing the square. So I wanted to summarize the different methods that we've used so far. So if you choose factoring, here's what you need to do. If you choose to use the square root property, here's what you need to do. If you're going to complete the square, here's what you're going to do. Now here's the thing about completing the square. it has its place. It really does. There's some uses for it. But if you hand me a quadratic and you tell me to solve it, seriously, completing the square is not what I'm going to do. And I don't think I'm alone on that. I think most of us are going to look at that and be like, yeah, no. In the next section, when we talk about the quadratic formula, that's probably going to be your go-to. You know, the square root property, it's like White Castle. You know, it's not somewhere you go, it's somewhere you end up. You know, nobody goes to White Castle, you just kind of end up there, right? That's kind of how the square root property is. Or sorry, the completing the square. Sorry, I didn't mean to say square root property. The completing the square property is kind of where you end up. All right, but I'm going to show it to you because who knows? You may like it. You may look at this and say, this makes perfect sense. I like doing this way. This way works with my brain. And in which case, go for it. Because I want you to do what works best with your brain and your thinking. So we've got this quadratic. You can solve this by factoring if you want to. How's Hawks going to know if you don't complete the square? Hawks isn't going to know. I'm not going to know. So if you see these that say complete the square, you don't have to. But just so I can show you how it works, you take half that middle term, you get 2. 2 squared is 4. Now, because we now have this in equation form, I have to add 4 to both sides to balance out that equation. Before, I was just completing the square and factoring it. Now that I actually have an equation, I have to balance it out. Factoring this, we know how this is going to factor. Remember how we color-coded this last time? That sign, and then that half of the middle term. Then we can use the square root property by taking the plus or minus square root of both sides. That'll get rid of that squared. And we get x plus 2 equals plus or minus the square root of 9, which is 3. I'm going to subtract 2 from both sides. This is 2 computations. Do not do 3 minus 2 and get 1 and then throw that plus or minus on the front. That's not how it works. You have to split this plus or minus 3 into those 2 and then subtract 2 from it. So 3 minus 2 is 1. Negative 3 minus 2 is negative 5. Remember, you don't have to solve them this way. All right? You can go back up here and just factor that by trial and error. Or if you already know the quadratic formula, use the quadratic formula. You don't have to complete the square. But I do have to show you so that I can say, oh yeah, no, they know how to complete the square. I taught them how to do that. Nah, you don't have to know that stuff. Okay, so for this one, I'm going to move that 10x over. So I'm going to have to move that over because in order to complete the square, we're going to need it in this form. So I move that 10x over, and then I move that 3 over here. That's because to complete the square, I need that x squared, the x term, and then kind of a blank, and then the constant over here. I think that's another reason. I really just can't stress enough how much I dislike completing the square because it's just so weird compared to some of the other ways. But we need it in this form. So we go through, we take half the middle term, we square it. We do that to both sides to keep the equation balanced. We factor this, using that sign, and that half of 10 is 5. Then we're going to take the plus or minus square root of both sides. Now this is messier, because the square root of 22 is not pretty. So we get x minus 5 equals plus or minus square root of 22. I'm going to add 5 to both sides. Now check this out. This isn't going to simplify. The square root of 22 doesn't have any perfect square factors, like 4 or 16 or anything. So these are your answers, just root 22 plus 5 and negative root 22 plus 5. This doesn't look very nice, but it's correct. So that's why I wanted to do something like this so that you can see that, hey, your answers may not always turn out really pretty. They might be kind of messy. Now, if you're wondering, does root 22 simplify? You can always grab your calculator out and do square root of 22. If it kicks the same answer back to you, then it doesn't simplify any further. All right, the next one is already set up for you in that completing the square form. I just need to figure out what number is going to complete that square. Well, half of 1 is a half, and then a half squared is a 4. Yeah, look at how messy this is getting. This is getting out of control, isn't it? So let's factor that left-hand side. Pay close attention to my use of color. It is very intentional. It's not just to, brighten up the place. You can use your calculator to do -2 plus 1/4 and get -7/4. Then we're going to take the plus or minus square root of both sides. It's looking ugly. And oh, by the way, we got a negative under that square root symbol, so we're going to have some eyes that are about to show up. Oh, look, there it is. So we get x plus a half equals plus or minus the square root of -7. Where did the 4 go? What happened? Well, this was the square root of -7 over the square root of 4. So I simplified that square root of 4 to just be 2. So notice the square root's gone down here. I'm going to take that negative out and write it as an I. I don't know if you guys can tell the difference, but I tried to do that in orange, and then the other stuff's in red. It might look the same. I hope not. So I get that plus or minus I root 7 over 2, and then, oh, by the way, we got to subtract 1/2 from both sides. So I could write the answer like this. If you wanted to pull these together because they have a common denominator, you could. And you can write it as -1 plus or minus I root 7 all over 2. Now look, notice if you split it apart, you get that -1/2. There it is. And then you get the plus or minus I root 7 over 2. There it is. So I just wanted to kind of show you how those split apart into that. Either one of these answers is okay for me and for Hawks. Okay, one more, and that'll finish up this really, really long and tedious section. So for this one, I'm going to have to divide both sides by 4, because this coefficient of x here, we can only complete the square if that coefficient of x squared is 1. So I'm going to have to divide through by 4. So I have to divide every single term by 4. In doing so, I get a much nicer equation. Now, let's be honest with each other here. At this point, if you can factor that, you should. This does not factor nicely. So what we're going to have to do is either use the quadratic formula, which is in the next section, or we got to complete the square. So I need to move that 4 over. In doing so, I get that -4. Then I have to complete the square. So I take half the middle term and then square it. So half of 2 is 1, 1 squared is 1. Add it to both sides to maintain the equality, maintain the balance on that equation. -4 plus 1 is going to be -3. Then I'm going to factor this trinomial right here. And pay close attention to my colors here. That plus comes from there. This half of 2 is 1. That's where that comes from. Now I'm going to take the plus or minus square root of both sides. That I is about to show up again because of that negative under there. I wrote that parenthesis by accident. I shouldn't have. That bothers me. I'm just, crazy enough to want that gone. Okay, so we're going to do this x plus 1 equals plus or minus that square root of -3. That negative is going to come out as an I. So I get that plus or minus I root 3. Now I do need to subtract 1 from both sides. And so what I did was I wrote it like this, by subtracting that 1. You could also write it like this. If you wanted to put that -1 first, and then the plus or minus I root 3, you could. This is 2 solutions, 2 complex numbers. One complex number is -1 plus I root 3. The other one is -1 minus I root 3. All right, those are 2 numbers. Remember, complex numbers have a real part and an imaginary part. This is one complex number. This is the other complex number. But we do have 2 solutions to this. Okay, so that ends section 10.1. If you don't like completing the square, hold off on doing that certification until we do the next section in 10.2 when we learn about the quadratic formula, because you might like that better, in which case then you don't have to complete the square at all. So If you don't like the completing the square, hold off on those questions. Wait till we get to the quadratic formula, and then you can just use the quadratic formula and get these exact same answers. So, okay, that concludes this very, very long section.